Hello and welcome to our webinar on functional safety with the ISO 26262. Vector is welcoming you to this webinar, and my name is Christoph Ebert. I'm presenting the webinar together with Jonas Wolf. This webinar is one part out of 3 webinars. We will first of all cover the principles and practice with a focus on concrete experiences which we made at Vector Consulting Services in applying the ISO 26262 with clients. The part 2 is about using our prevision modeling environment for the ISO 26262, which will be on the 30th of April. And part 3 is about using Microsoft Safe environment with the constraint of functional safety. This webinar, the 3rd, will be on the 7th of May. So I welcome you for all 3, and we will start with part 1. And the structure of this webinar is that I will give you a very brief overview on Vector. We will then go into some basic concepts about how the standard is structured. We will then have the core part, which is experiences on safety management, safety development, and support processes. And I will conclude with a brief summary and an outlook what the standard means for different market players like OEM Tier 1, but also what will be the evolution. Vector on a worldwide scale has currently around 1,200 employees with a fast growth rate in double-digit per year. We work across the world in different locations and are active in a number of fields. Amongst them, we have consulting services. The consulting services apply to engineering, management, and implementing change. Some examples which emphasize these topics are, for instance, improvement in the system, software, and hardware engineering, or functional safety introduction, where our today webinar is a small part, but also process frameworks such as CMI and SPICE. In the management arena, it is project and crisis management, but also geographically distributed development. And on the side of managing organizational change, it is efficiency improvement, cost reduction, and implementing changes such as introducing a new tool, which is often a profound change, or introducing lean and agile development, etc. Within consulting, we are active in different industries which are all related to critical systems. Majority of work is in the automotive sector, but we also benefit from experience in aerospace, energy, healthcare, and transportation, which are all safety critical topics, and IT, which has other type of criticality. Our safety solution portfolio, which you can also find at www.vector.com/safety, has first of all the introduction of safety processes such as performing the safety check to see about the maturity of an organization with respect to using the 26262, training, coaching, and tool support. Then safety management, with, for instance, topics like provisioning interim safety managers for development project at customers, safety assessment at suppliers, or improving the interfaces between, for instance, an OEM Tier 1 and a Tier 2 with respect to functional safety. A third topic is safety engineering, where we, for instance, help in introducing components and platforms such as Microsoft Safe facilitating safety analysis from hazard analysis, 2 different techniques like FMEA and FTA, and the development and review of safety concepts, for instance, also when it comes to how different tools, be it from Vector or other tools, are used within your life cycle and are used in order to ensure that you keep a specific ASIL level. After this brief introduction, we will now look into basic concepts of the standard, just that we have the right motivation. I keep this short because I assume that most of you have already been exposed to the standard. As said, the majority of this webinar should be on practical experiences. Functional safety has a broad exposure. We see that with the growing interworking of a variety of assistance functions inside the car, that all have, for instance, elements of impacting the driving dynamics, and that of course then could create safety risks for the driver, but also for the public. And for that reason, there's a growing need due to this broad exposure of the EE functions to make sure that they perform as intended in order to limit the liability risk. Functional safety not only has a broad range of different functionalities, but also wide impact across the life cycle. If we see the life cycle, it's not only related to, for instance, testing, but it's indeed end-to-end from a system concept to the different implementation steps up to the integration and release, including also field operation. And we show with these different colors how different activities are impacted by the 26.26.2. And what it also means that clearly OEM and suppliers are impacted. Even if the liability is initially with the OEM, certainly the supplier has also to make sure that he follows with his components the overarching safety requirements. Functional safety can be achieved with many different techniques. So from a mere economic perspective, we should also be aware that we use the right methods and techniques. We have seen with customers often a kind of overkill in certain arenas on the right side of the V, a lot of overlapping verification validation techniques, which in the end create extra cost but not much extra value from perspective of safety, and maybe even provoke certain gaps just because there's a mismatch in understanding the methodology. So we need to intelligently combine techniques for fault prevention, detection, tolerance, and then also failure prevention. And only this intelligent combination can make sure that the standard is useful also from an economic, that is from a cost-benefit perspective. Finally, the standard ISO 26262 is a rather complex standard. It has 10 parts, which are briefly described with this picture. We will later on come back on some of these parts, but just to give you an idea, there are certain parts which all standards have, like a vocabulary or guidelines for usage. But then there's 3 core parts: the management of functional safety, which is book 2, the engineering process, which are books 3 through 7, where production operation would also be related to that, because we have to supervise the way how components are put into field and would be, for instance, upgraded, etc. And then we have support processes, such as tool usage, etc. And then we also have a chapter 9, a book 9, which shows how the ASIL oriented safety analysis is done. All that creates some 600 requirements that have to be addressed, and you see from this mere complexity that if the standard would be bluntly copied in terms of, let's say, let's do this and that and that and that, can be extremely expensive, and at the same time maybe still create gaps because of misunderstanding of what is the intention of the standard. In other words, there is a risk of overhead and bureaucracy which has to be handled, but there is also a very big risk which we often face, which is uninformed usage of the standard. If we develop safe products, this has to do with a trust into the products, but also it has to do with what the ancients have called a moral commitment. I quote here Werner von Siemens, who said the prevention of accidents must not only be considered as a regulation by law, but also as a matter of human commitment and economic reason. What he emphasizes here is a mismatch which we still see today, that we sometimes hear what do we have to do with respect to the standard so that we are safe in case of lawsuits. Now, this is certainly a strong motivation which many of engineers are driving, but initially we should rather think in terms of what do we want really to deliver as a product, what is the market perception, and at the same time also what's our business reasoning. As I said earlier, each of the requirements of the 600 requirements of the ISO 26262 creates its own cost-benefit calculation. So we have on one side a legal obligation which is certainly there and which is growing, but at the same time also a clear market and business perspective which helps us to balance the different requirements with respect to the business value. Now, what does it mean to build a safe product? The simple answer would be it should be conforming to the current state of the art of science and technology, which is typically brought together by, let's say, publications and at the same time also standards such as the ISO 26262. Such a standard summarizes the current state of the art and would be used in the case of a lawsuit, so to see whether the supplier has followed the principles which should be applied when bringing a product to the market. And this is exactly summarized also on the right side, where we talk here about the product liability, that a product put into service must provide the level of safety which can be expected by general public. When we say general public, just as a side comment, this is what in automotive is a big difference to some other disciplines such as aerospace or transport, where the assumption is clearly that the drivers, the operators have been severely trained and utilize this training. This is something which we would not expect from car drivers, and that makes the design of the product a little bit more difficult compared to what we see in, let's say, transportation. Now, with this concept that the supplier must make sure that he follows the state of the practice, we also have the legal principle that the supplier, in the case of damage, has to prove that he has actually performed the state of the practice. This is what we have called the reversal of evidence, and what it means is that he should at any moment be able not only to tell I have a certain standard applied, but also document by means of work products how this standard had been actually applied in the concrete design, development and production of a specific component. Now, in order to facilitate that without much overhead, ISO standards have been created to mutually support each other. We have, for instance, process-related standards which are based on the ISO 15544, which relate very nicely to quality management standards such as the ISO 9000 series, and then specific standards for quality requirement, such as, for instance, the ISO 26262, The idea is that companies should apply all these standards so there's not a big overlap. For instance, 26262 demands traceability from requirements. Now, it does not really go into much detail because the assumption is that people are knowledgeable of the frameworks such as CMMI or SPICE, which explain how a requirements traceability, a bidirectional traceability, is actually implemented in practice. This is how standards mutually support each other without creating huge overheads, because each standard repeats what other standards are telling. In other words, it's very clear that maturity models and organizations who have used the maturity models with respect to maturity level 2, 3 in CMMI or SPICE have certainly a big advantage in implementing ISO 26262, while on the other side, if we would only jump on the ISO 26262, and this is what we often see in practice, without a decent defined set of processes, many of the changes tend to not really get into the culture, because at a given moment suddenly people would fall back to previous behaviors. The entire idea of process culture, of making sustainable change, is something which is explained by ISO 15054 and for instance CMMI. The ISO 26262 is using these concepts, and this is why we say the application of these frameworks is expected. It's not mandatory, but clearly is a huge advantage. The scope of the ISO 26262 is initially in the domain of passenger cars, which go into series production with a weight of below 3.5 tons. Now, what it actually means, if we take this, is a rather small application domain, but we see in practice many companies which are active, for instance, with the truck industry or the vehicle industry, the off-road agriculture industry, that they would not only use specific standards such as the ISO 25119 for the agriculture domain, but would also increasingly have a look to the 26262 because of its wide range of usage and a much bigger body of experience compared to the rather narrowly used specific standards which we face in the vehicle, agriculture, etc. domains. In other words, what we recommend these days is that with specific standards such as machinery or agriculture related to functional safety, it's worthwhile looking into what are best practices out of the 26262. Maybe even implementing the 26262 to the certain degree that it covers the specific domain standards, but actually you benefit with respect to methodology, with respect to best practice, with respect to tools from the wealth of experiences of the 26262. We have already zoomed into the 26262. What we want to emphasize again is that it is a very systematic and structured approach with 3 basic domains, which is the management of safety, the development of safety, and supporting processes in order to keep certain safety processes up to date and also related to each other. We would then start by looking to the broad concept of ASIL classification, because this is at the core of the standard. And what we see is there's a set of factors which altogether give us a risk. The risk has to do with the exposure, the way we can control the specific risk, and a severity, which is to which degree would we really have casualties or accidents with, in the case of a malfunction or failure, and as a counterweight, what is called integrity, which helps to balance the 3 other factors. The picture on the lower part explains this briefly. If we expect the tolerated risk for any component in a car is achieved by means of QM, which has been a long tradition, then adding some functionality could increase the exposure, could increase the severity. A brief example would be if we had in the old days a pure non-electric way of steering wheel, of braking system, etc., or of any kind of dynamic functions, adding some assistant function like an ESP or an ABS, etc., obviously adds to the risk, because suddenly some failure in these components can, for instance, mean that the brake or the dynamic stability is not anymore given. So this would mean that actually we move here to the right, and we have to compensate, and this is done by seeing to which degree do we move to the right, where the letter D would be the highest need for additional measures, and these additional measures then bring us back to some, let's say, residual risk, which should be lower than what is the tolerated risk in a specific environment. A second key element of applying the standard is that we have to make sure to address both random and systematic faults. Now, random faults have to do with typically hardware faults we cannot really predict, we can only statistically analyze, so we have to diagnose, we have to monitor, we have to make sure that we have the right level of testing, etc., in order to immediately highlight if there is a malfunction on this hardware side. For the systematic faults is a little bit more critical, because they have to do with the way we design, develop, and engineer, and finally test the product. So here we need methodological, or if you want, systematic measures, starting with analysis and design techniques up to consistent traceability and proof of safety. So these are two very different approaches which both have to be applied in order to make sure that we are able to reduce the risk in the way as the previous slide has just showed. Now, the determination of an ASIL level, as we have indicated before, has to do with severity and probability of exposure, of control, and finally the related integrity. In other words, if we have certain controllability, which would be here in a range between 1 and 3, let's say we take the middle, we have a certain severity which is high, and we have a certain exposure which is also rather high, so we have a combination of C2, S3, E3, controllability, severity, exposure, gives us then a clear mapping towards what would be necessary from a perspective of safety integrity, and in that case it would be what is called ASIL B, which is automotive safety integrity level B. Now, we can see with that small example that if we would increase the exposure, we immediately run into ASIL C. The same if we would have less controllability, we would also be in C, and if both of that happen, we would have even the ASIL D, which is the highest of the 4 ASIL categories. And according to each of those, we would then have specific measures to apply. Or in a practical example, as here, we talk about a brake-by-wire system, and you see that we need to look into specific use case in order to identify hazards, which would then tell us what would be the ASIL level in this specific situation. To summarize this part, there is not a kind of external ranking of systems which would tell you this system has an ASIL X and this has an ASIL Y, but it really depends on the specific use case. It depends on the design of the car, how and which of the ASIL levels would be really applicable. Now, we want to briefly look into some of the experiences in implementing functional safety, and at the starting point, we identified a set of typical questions which are asked to us by customers. how this or that is done. We want to emphasize, and you see that in the gray boxes also again and again, that it is not wise to try to copy the standard into your engineering processes. This has to be done intelligently in order to avoid unnecessary overheads. Let's start with safety management, where we look into two domains as examples. First, to set up safety management, and then to integrate the safety life cycle. First of all, setting up safety management means that we have an effective and at the same time lean management of all safety aspects. Now, some of the guidance which we typically provide, and again, this is not a complete cookbook, it just gives you some ideas how to implement the 26.26.2. For instance, here what we show is that we have a clear set of responsibilities and interfaces, that we make sure that safety culture is implemented top-down. For instance, what we often see is certain safety measures such as specific code reviews, unit tests with a certain coverage of C0, C1, maybe code analysis, etc., would be done in the development of ECU software. However, suddenly under pressure, people would step backwards and would not anymore do these activities. And they would say, well, we still have tests somewhere later, and they would find the defects. This is a clear indication that there is not a safety culture. And obviously that is also something which in the case of accident where you should prove what you have done, you would clearly fail, because then what would be not available is consistent documentation about how safety measures have been implemented. In other words, safety culture starts top down. There's no way building up ISO 26.26.2 bottom up. What can be done is, of course, that senior management would be specifically trained and coached in order to understand the needs, but at the same time also pushing, and that is their fair right, pushing the engineers into a lean application of the standard in order to be more cost effective. A second topic which we often see is a misinterpretation of what does it mean responsible for safety. In the meantime, most organizations have started to implement what is called by the standard a safety manager. However, what we often see is that people would then point to that safety manager and would say, well, if it comes to safety questions, this is the person. This is obviously not the idea of the standard. What the standard clearly says, and what is normal, is that the role of the safety manager has to do with coaching, has to do with planning safety activities, but the execution is a regular engineering activity. It's the same as each person who is writing a work product should also do the respective reviews to identify defects. I mean, we don't send a document to someone else if we don't have done our own review on that. And that's the same with safety. As an engineer, we should always personally check that we deliver the right quality level. So safety has not to do with pointing to the safety manager to do all the work. It has more to do that each role has its own responsibilities. And this is part of the culture change which I already mentioned, that with knowing all these responsibilities, we also know that there is a budget need behind. And it's evident that if you go from 0, that is QM, to an ASIL, let's say CD, the additional cost, which is somewhere in the range between 30% and 100% plus, compared to the old behavior, is something which has to plan, to be budgeted, and where also the competences have to be trained. It's insufficient to just assume somebody would get onto a safety training, would be the expert engineer doing a criticality or hazard analysis. In other words, this has to be planned, competences have to be continuously updated, and this means what we call early safety needs profound culture change. Now, second topic here was integrating safety lifecycle with different project activities. What it means is that a key concept which we learned over the years is we should not make a kind of a shadow safety process, but rather integrate the safety activities with the regular project activities. That is, the project planning would include also the necessary safety activities, which could of course be tailored according to the ISIL level. Or for instance, when we talk about interfaces, which we often have in the supply chain, we need a development interface agreement, a DIA, which would then also be used by the safety plan as a reference on the responsibilities. To put that in a picture, we have here again the V, and the V would be determined by a project plan, and each of the safety activities, be it now the item definition at the very beginning or hazard analysis, or some quantitative safety analysis later on the right side of the V, all these different activities would be part of one project plan, not of a separate additional planning, which would then often lead to confrontation, because how would we then make the full estimate, because at the end each single engineer has to work both on safety and on engineering. Similarly, this picture shows that this blue part, which is the traditional project planning, would be extended by the elements on the right side, which have to do with safety and a different way of looking into, let's say, verification, validation, or safety assessments, etc. But they would be extensions to the normal project plan, and not something which goes fully in parallel. In other words, what we want to highlight is we not have a silo which is called project plan and another silo which is called safety, but we rather have a safety plan which consists out of a project plan with certain extensions that, for instance, depend on the ISIL classification. Having now looked into management, let's proceed with development. And here we identify two topics which we have seen very often misunderstood, or we find that guidance is necessary. One is to better include the customer, and the second one is adjusting the development process according to specific safety needs. Now, including the customer means that independent where we are in the supply chain, we should have a good understanding of how our component is actually used on a next higher level. This means, for instance, if we would be a supplier to an OEM, that part of the systems analysis, of course, would need our component, but at the same time also would have a need to show us what's left and right of our own component in order that we can make the right system level functional safety analysis. As a guidance, what we often recommend at the very beginning when people get confronted with ISO 26262 is to go through the regular process of engineering and then make sure that the necessary safety related responsibility, which later on we also have to document, would be mapped with the RACI schemes, so that we know who is responsible, who is accountable, etc. At the beginning, so that we also have the visibility about how specific roles would interface with each other and would contribute to making a product safe. Also, as another recommendation, that the activities which the 26262 demand, these 600 requirements, after some tailoring, would be part of the regular project planning, so that there's also sufficient effort budgeted. Here's an example of DIA as it could be done. This is now done together with on the basis of an Excel tool. At the same time, you can also use any type of responsibility or workflow system. The important part is that we have a way to tailor the content in a way that in some cases we need an activity, in some cases we don't need it. And we have clear mapping of responsibility. So if there's later on a need, we can always trace back and say this is what the person X had done in order to keep the product safe. Another topic which we often see is that the development process needs to be adjusted to be consistent with the 26262. And that is, for instance, as a key recommendation that I mentioned already earlier, that we use process frameworks, ISO 1554 based frameworks such as CMI and SPICE, which are widely known and applied in the automotive industry as a kind of baseline in order to have a process framework where specific safety-related activities would then be anchored. For instance, CMMI or SPICE demand clear verification validation, that is the right side of the V, and evidently this is where later on certain review and unit tests and other activities would plug in, so that these activities already have their place and would not happen in isolation, which we sometimes see where people would just buy, let's say, test tools and then come back to us and ask, so dear Vector, how do you make sure that your test tools work in all environments? And then we have to explain, first of all, that it depends to the degree the life cycle is structured on the customer side. Another example would be to consistently document safety goals. Here is an example where we also show that these documents can be done by different tools. In the case here with our Prevision environment, but there are others you can also do. But the important part is that any of these content would be related to each other, would link into, let's say, modeling or other environments, so that we can easily see if there's a change, what it means, and whether we've already done some activity. And then obviously the standard also gets very much into how do we achieve safety in our design, such as in the example here, depending on the ASIL level, specific recommended measures for the software development. And you see again that on the lower safety integrity, such as ASIL A, we would rather have topics such as a walkthrough or strong typing. That is something which we always learn in school. While on the higher level, we talk about diverse and redundancy. We talk about specific performance and resource tests, etc. So we see already here a very big difference from, let's say, normal work as we would do in any kind of environment, up to very specific safety-oriented ways of handling. Now, the standard typically shows this by means of 0, a plus, and a double plus, where the double plus means this is a highly recommended practice. So you should think twice if you decide not to do it, because at the end of the day, this helps you to deliver a product which satisfies market needs. But at the same time, as we said initially, it's also your own safety net in case of liability. Examples how this is hierarchically structured is, for instance, software unit test, where we have a set of different verification activities, first of all, in the standard. And then, if we zoom into the standard, we would certainly see, well, here's now a very specific detail for unit tests, which is, for instance, different type of coverage, such as C0, C1, or MCDC. And you see that with a higher safety and criticality level, it's clear that we move from a plain statement coverage, which is what I would expect all of you are doing, into a more concrete MCDC coverage, which would then also look into what are the decision paths in the software. In the last section, we want to look into some support topics, and here I want to emphasize two things. First, how do we manage safety requirements? So we talk a little bit about safety requirements and the requirements specification, and then in a second part about tools usage. The target is to create maintainable and traceable requirements. Now, this is a target which holds for all requirements, but it evidently holds specifically for safety requirements. So we should use systematic and structured techniques for eliciting and specifying requirements. We should set up and maintain bidirectional traceability, which is maintained throughout the project. That's, by the way, something which is hardly possible if you work only with Excel sheets or Office documents. This is really something where we strongly recommend tools. But at the same time, also, for instance, to think about test criteria at the time when we specify requirements, in order to make the requirements testable, and at the same time also make sure that we have somewhere on the right side of the V some equivalent to the initial requirement, which is then also used to check whether the requirement is implemented, specifically in the case of regression. Some examples: the managing of functional requirement. Again, we use here the prevision environment as a requirement tool, which is then showing specific requirements and how does it link to our hazard analysis and what it means in terms of safety functions, so that we can, for instance, apply automatic consistency checks. For instance, if there is a small update, correction, a variant release, that we have still all necessary checks and analysis completed. A second example would be how do we specify good requirements with the target of traceability, and what we show here is, for instance, we should keep the scope of a requirement rather small. We call this atomic. We should have short sentences which are comprehensible, and we should use, let's say, understandable language so that different users would come to the same conclusion. And again, it's of very good engineering practice to think always when writing a requirement also about the test. That holds, by the way, on all levels of the development, not just for system level requirements, but also for code level requirements, which would then translate into what is today called test-driven development. Secondly, we look into tools usage. I mentioned already that office tools do not really bring much value and are extremely cumbersome when it comes to maintaining different variants, for instance, over the life cycle. So here a strong recommendation is to have a professional tool chain which has workflow support, so that the responsibilities can be automatically assured, but also are documented later on, so that we could see a document had been released after a review, etc., etc. Of course, we should make sure that the tools are perceived useful in order that they are used. Sometimes we see rather nice, sophisticated tools at customers which had been bought because some person told them, well, this tool is quite helpful, but at the end of the day, the tool is not really used because people had been insufficiently trained, or the environment of the tool is insufficient, and that certainly doesn't help much. So tools should satisfy different type of usage needs, such as security, performance, collaboration across sites. And this is something where, as I said earlier, we often help customers to set up an adequate environment which is specific to their geographic layout, but also to their, for instance, customer and supplier relationship. Here's an example of tool-driven hazard analysis and risk analysis, where we would have some single base for the hazard analysis, on which we then would derive the safety requirements, and of course can then also generate automatically documents which would be used, for instance, in order to see which of the cases have already been applied. Or equally, with the growing understanding that only with a decent model-based analysis and documentation we really have a full picture of different functions and their interaction, we would also see that it is extremely important in the initial spirit of UML that we have a single source to which we look with different perspectives, that is used starting with the hazard analysis and the functional specification up to the right side of the V with all type of verification validation activities. And that brings me also to the tool-based validation of a safety concept, which means that the left side and the right side of the V would be connected in what we call traceability between design artifacts and the implementation. Again, here tools are extremely useful because we can, by simple drag and drop mechanisms, make sure that we have the traces established and we don't have to start typing something into Excel. As an example of such tool chain, here's what we are doing in our AutoSAR development. You see along the V a set of interworking tool. This is a workflow which starts out with the prevision used for modeling analysis, the DaVinci for architecture design, then on a lower level the configurator of DaVinci for the specific ECU development, and upwards Canoe, being a testing environment, Canopy for the calibration. So This is a suite of vector tools. You can, of course, also use a federated suite with different tools. The important part is that these tools fit together and are really so much connected that if there's a change somewhere, it ripples consistently throughout the whole V. Now, one question which we often get is about tool qualification. We should not blindly trust the tools which we use because most tools need to be qualified in the environment where they are used. The ISO 26262, for that matter, also has looked into qualification of tools, which is basically related towards the degree, what is the impact of a tool, such as is the tool directly responsible for generating some or impacting some product, for instance, a compiler, a modeling tool, any kind of calibration data, etc. This is a directly product-related impact. While there's also, let's say, a documentation tool, which is not directly product-related. A second one would be tool error detection, which helps us to which degree would we detect a defect or the tool itself detect a defect in when using the tool. If based on these two factors, the tool impact and the error detection level, we come into a tool confidence level, TCL, where the TCL 3 would be the one where we have to pay most attention because it means that we should very well analyze in which context the tool is used. And then, of course, the standard also gives recommendations such as to which degree the development process of the tool has been according to standard, etc. To summarize now, after this brief overview on safety measures and to still allow some time for question and answers, what we face today is an increasing amount of complexity caused by a huge amount of different functions based on EE, equipment, assistant function, etc., which increasingly interwork and at the same time also have an increasing impact on driving dynamics. And that, of course, means that we need to grow the competence in the same way, but as we are all aware, we not only have a lack of engineers, but we have a clear lack of safety experts in most of the companies, and for that reason it is important that process and tools to a high degree facilitate that those scarce resources can most efficiently work in implementing the ISO 26262. And that's yet another example why we highly recommend having an adequate workflow and tool environment for your engineers to make sure that they wouldn't waste their scarce energy on things which can be really automated. Safety demands tailored solutions, starting with the product. We have to understand the product, we have to understand the hazards, and we have then to see how, by means, for instance, of redundancy or reuse, we would be able to optimize or balance cost and benefits in terms of achieving safety. From a process perspective, we already emphasized that there is a strong benefit from being already exposed to CMMI or SPICE, not only because it helps with continuous improvement, but also it gives a good baseline of process culture across the company. Thirdly, people. We talk here about competences, we talk about skill profiles, but we also talk about culture. As I said earlier, it's pivotal that the engineers understand what is their responsibility and impact on achieving functional safety, and no one in the company should simply point to a safety manager as being the safety expert, because that clearly brings you in a situation where the safety manager not only becomes a bottleneck, but also would not be really able to do even his job, because he is not the person who has to engineer for safety. Where do we go from here? If you look to automotive OEMs, it's about process capabilities to improve. Most of the OEMs, all with whom we work, are very capable with respect to understanding the 26262, but it's now more important to think in terms of what kind of collaboration is necessary on the systems level, where still a lot can be improved. Tier 1, Tier 2 suppliers of established safety critical components typically have a need to better connect into field observation abilities also for a complete safety case, so that specifically the life cycle support is sufficient. Often what we see with OEMs is that it's hard to have a full picture of what are the ECUs, what are the dependencies in a specific passenger car, let's say 5 years or 10 years after it has been initially put into the field, where so many changes have been made. It's very difficult to still manage all these dependencies. Now, for suppliers of new innovative components, for instance, along the electric powertrain, battery systems, etc., here the need is to quickly ramp up because the market doesn't really give much window to recuperate. So this means reuse best practice concept, introduce state-of-the-practice tool chains, etc., so that you can concentrate your energy on your product and not so much on ramping up the ISO introduction. Finally, the standard, of course, is not frozen. It is evolving based on the feedback from its use. And we see also more and more that we are asked to perform a supplier evaluation on the basis of the ISO 26262 because, for instance, an OEM who would be directly in the fire line in case of a problem on the field want to make sure that his suppliers adequately perform, because it's of not much help, as we have seen in some of the recent media releases where an OEM would put forward because some system had not been performed, that these OEMs would have a strong benefit that they have a consistent understanding with their different suppliers about how to achieve functional safety. So our recommendation here is, given that these resources are scarce, that you always think in terms of what would be the best combination of our own resource, maybe also resources from a partner like Vector, in order to implement a mature development process, management process, which is used in your organization. This having said, brings me to the end of this webinar part. We will now have some minutes where my colleague Jonas Wolf looks into the some of the questions which we have received over the past hour, and then we would just select 3-4 questions and then finalize and conclude the webinar. Jonas.
Thank you. One question I selected was the question if the performance after ISO 26262 guarantees an automatically a definite CMMI level, and of course not, because they have different focuses. But still, if you have mature processes, which in turn is good evidence for appropriate CMMI level, you're very well prepared for safety relevant development. The other question was how is distributed development addressed by ISO 26262? It's addressed, as Christoph already said, using the development interface agreement. This may be applied to customer-supplier relationship, but also for distributed development within the company. Then we had the question regarding what tools can be used for model-based presentation. And as you saw on the slides, Vector provides here a solution which starts at the system level, which is called Prevision. And it fully integrates into Vector's other tools like Canoe, which helps you in system validation. And then we had another question that is how those weak requirements in the tables, like recommended, highly recommended, should be handled. And here's our proposal to tailor your development according to the ISO 26262, using your, for instance, safety plan, and provide reasonable justifications for your selection. And the almost last question I have is, what's the difference between semantic code analysis and formal verification? It's from one of the tables in part 6. The semantic code analysis is performed using a tool that examines your source code and provides you with information about its behavior, whereas formal methods are a distinct mathematical model, where you use a mathematical proof to show specific properties of your system or software. And the last question is if the presentation will be available for download, if it will be available for download. And as our host already said on the chat, we will provide an email link, and this should also be a reminder for the next 2 webinars we have in this series of 3.
Okay, thanks a lot, Jonas, and that brings us to the end. I appreciate very much your listening to this webinar. Hope that you got something out of it, and evidently within 1 hour it's always a decision how much can we package in without overloading. There's much more experience, so you might also want to go to one of the following web pages, such as our www.vector.com/safety, which gives an overview on the full safety portfolio with the consulting, with the tools, with the way, for instance, we qualify and develop our tools, but also a link to microsar, safe, provision tool, etc. Then we have, specifically for the consulting, the www.vector.com/consulting page, which gives an entry portal for our different consulting activities. And if you are not sure really where you are and what your exposure is and what your strength and weakness are, we recommend using our safety check, which is a brief 1-week exercise where we go end-to-end through your process and provide you with recommendations specific to your application domain. Some details you can find at www.vector.com/safety-check. Again, thank you very much for joining. Keep in mind that we have further webinars to come, and if you have downloaded this webinar, you might find more related recorded webinars at our safety page. Thank you and goodbye.